Okay, so we're about to get into factoring trinomials, right? So I just like to show this as an activity just to help you understand what's really going on when you're factoring trinomials. So really what we're doing is we just really are thinking about numbers, and we're really just basically trying to come up with different pairs that can create the situation that we are given in the problem, okay? So we're just going to play around with these just so you can understand how your mind is going to be working when you're doing these factoring problems of factoring trinomials. So it's almost like a game. We have to figure out what two numbers we can use that would create a product of 12 and have a sum of 8. So when we say sum, we are saying any combination that creates a positive 8, whether they are positive numbers, negative numbers, adding and subtracting, whatever it is. How can we create a product of 12 and a sum of 8? And what numbers would we use? Okay, that's what we're trying to figure out. What are two numbers that can multiply to create 12, add or subtract to create 8? And that's what we're thinking about in our minds. And so what you're supposed to do, or what you should do the best way, is to use the product and use the factors that can create that 12, and then it'll be easier for you to find the numbers that can somehow add or subtract to create an 8, right? So essentially you look at 12. What are the factors of 12? Well, 1 and 12, 2 and 6, 3 and 4. So when you look at that group, at those groups here, what pair will actually also be able to give us a sum of 8? So 1 and 12 will never create an 8. You can get a 13, you can get an 11. 2 and 6, we can get an 8 if we add them, or we can get a 4 if we subtract them, and then we can do negative numbers, right? So positive 2 and positive 6 create a positive 8. Well, that's my pair right there. So plus 2 plus 6 creates 8. Plus 2 times plus 6 creates positive 12. So our two numbers that can have a product of 12 and create an 8 are 2 and 6. Okay? All right, next, we're looking at a product. We're looking for a pair of numbers that can create a product of negative 10 and add or subtract to create 3. So you should use your 10, and you should do your factors of 10. So I got 1 and 10, 2 and 5. Remember, it's a negative 10. All right, and so this is in our mind. What creates a negative? Different signs. And when we're saying creates a negative, we're doing products. So the signs of the factors are going to be different in order to create a product of negative 10. So we look at the pairs 1 and 10, 2 and 5. Can 1 and 10 ever give us a 3 if we add or subtract 1 and 10? No. 2 and 5. Can we ever get a 3 with 2 and 5 adding or subtracting? Sure we can. So now we have to figure out exactly how would we get the 3. So if we have a positive 2 and a negative 5, we would get negative 3. That's not the number we want. If we have negative 2 and positive 5, we could get the positive 3. And if we multiply a negative 2 times a positive 5, what does that give us? It gives us the negative 10. So you have to make sure that whatever numbers you find that work, that they can actually create the product and create the sum that you need. So here my numbers would be negative 2 and a positive 5. Negative 2 and positive 5 can multiply to create negative 10, and they can add or subtract to create a 3. So it's really like a nice little puzzle game that you're playing. You're trying to figure out, okay, what are for the next one, what numbers can multiply to give us negative 24 and then add or subtract to create a negative 5. So you should go through the factors of your product. So we're going to list the factors of 24. 2 times 12, 3 times 8, 4 times 6. So in this list, I'm going to then see, okay, which pair do I think could probably give me a 5? Well, I'm looking at the 3 and the 8, right? Yes. So how can I get a negative 5 with 3 and 8? Well, I can use a positive 3 and a negative 8 and get a negative 5. And if you multiply positive 3 times negative 8, you would get the what? The negative 24. So what are the numbers? You would use a positive 3 and a negative 8. And that's what we're doing when we're factoring trinomials, essentially. You're trying to identify what pair of numbers can create this outcome that we're looking at. All right, so see if you can do the last three. Pause. You're looking for product factors of 20 that can add or subtract to give 9. Factors of 36 that can add or subtract to give negative 13. And then factors of 10 that can add or subtract to give 9. So you should pause it and try those on your own. Okay? Pause it and try those on your own. I'm going to pause it and do it, and then I'm going to show you the answers. All right. So let's look at 20. When we do the factors of 20, we get 1 and 20, 2 and 10, 4 and 5. Well, the pair that can create a 9 in that list is the 4 and the 5, right? So 4 plus 5 can give us 9, and if you multiply them together, they'll give you the 20. Next, we have 36, and we're trying to get a negative 13. So we list all the factors of 36, right? We list them in their pairs. And so which pair do we think can create the 13? Well, I'm thinking the 4 and the 9. So we need a negative 13. So negative 4 and negative 9 create a negative 13. If you multiply a negative 4 and a negative 9, they will create the positive 36, right? So you have to have the pair that can multiply to give you the product you need, and then add and subtract to give you the sum you need. And then the last one, we had 10. Factors of 10 that can give us a 9. Well, the factors of 10 are 1 and 10, 2 and 5. 2 and 5 will never be able to add or subtract to create a 9 for us. They can give us a 7, they can give us a 3, and then they can be negative 7 or negative 3, right? But we looking at 1 and 10. We can get a 9 with a 1 and a 10. So when we do, I tested a positive 1 and a positive 10, it gives us an 11, so that wouldn't work. But if I do negative 1 plus 10, it does give us a positive 9, which is what we need. But then we need to double check. Is negative 1 times 10 positive 10? Negative 1 times 10 is negative 10. If you don't get double checks, then that's not your pair. So you have to have a pair of numbers that can give the product and can also give the sum. So I can get the sum of 9, but I can't get the product of a positive 10, because only the way I can get a 9 is if the signs of the 1 and 10 are different. If they're both negative, negative 1 plus negative 10 is a negative 11. So that still doesn't give me the 9, but those would multiply to create the positive 10. But what do I need? I have to have double checks. So if you cannot find double checks, what does that mean? It means that it's prime. It means that there are no factors that can create this combination. There are no factors of 10 that can also create a positive 9 if they are added or subtracted. Okay, so let's look at what this means for us in terms of us actually factoring trinomials. Here we go. So the trinomial is set up, right? All right. So we have the trinomial here, right? So trinomial, you have a quadrat. Let me see what they call it before I jump the gun. They just call it trinomial. So this is a trinomial. Ax squared plus bx plus c. All right, where your a here is always equal to 1. All right, so trinomials, 3 terms. So we have x squared plus 8x plus 12. So when you're trying to factor a trinomial, factoring trinomial. All right, remember factoring is creating a product. All right, so when we're factoring trinomial, we're trying to break it up into 2 binomials. So we should have 2 sets of parentheses. When you're factoring a trinomial, you want to always look for that GCF first, if you can. All right, then you do factors of C that add or subtract to get you the B term. All right, so factors of C, factors of 12, that'll create an 8. So we just did that on the other sheet. Remember, factors of 12, that'll give us an 8. What did we say those numbers were? We said they were 2 and 6. So what are we doing? we're breaking up the factors of the first term, and we're looking for the factors of the last term that we can put in the parentheses that when we multiply it, it'll create that whole trinomial. So what creates the x squared? X times x. Please remember that factoring is what? Going backwards to what it looked like before we multiplied it, before we distributed it. So what creates x squared? An x times an x. Well, what created this 12? Well, that's the work, because you can't just create a 12. You also have to make sure the values can add or subtract to create that middle term 8. So what did we say? We said it was a 2 and a 6. So when we factor, we should create these two binomials multiplied that if we were to work this out, meaning use our rules from chapter 12, from chapter 5, we could distribute this out so we can check it. And look what happens. We get back the original problem. So you're going to use, most of your work is just scratch work. Most of your work is trying to find the factors that work to factor the trinomials. All right? All right. X squared plus 9x plus 20. So we're looking at what? We're looking at factors of 20 that can add or subtract to create a 9. That's what you have to do. You look at the C term to see what factors you can use that would also be able to add or subtract to create the middle. So you do your two sets of parentheses. I know my first terms is just x and x. So you always look at the first term and you look at the last term. So split up the first term and then figure out the factors of the last term that's going to go in these two positions. Okay, so what are factors of 20 that can create the 9? Well, we did that. It's a plus 4 and a plus 5. And if you multiply that out, you will see that you would get the original problem. X squared plus 3x minus 10. X squared plus 3x minus 10. So what we want to do here, same thing. We're looking at it, all right? So we do factors of negative 10. That can give us a 3. So factors of 10, 1 and 10, 2 and 5, right? We did this one. So what are the factors of 10 that can create the 3? The 2 and the 5. But how do they create the positive 3? We use a negative 2 and a plus 5. And remember that multiplication is commutative. What's that mean? It means if you have it as x plus 5 times x minus 2, it means the same thing. It means the same thing. Because if you multiply it out, you're still going to create x squared plus 3x minus 10. And that's what we're doing when we're factoring trinomials. That's what we're doing when we're factoring trinomials, when our a is 1. Okay. A squared minus a minus 42. All right, so we're looking at two sets of parentheses. A squared is going to split into what? A and A. And then factors of 42 that can give us a what? What is the value we're looking for in the middle? Well, it's a negative 1, right? The coefficient on that A is a negative 1. So you're looking for factors of 42. So when I list my factors of 42, 1 and 42, 2 and 21, I think 3 and 14. But 7 and 6 is what I'm guided to. So 7 and 6 can create a 1 for me, I feel like. But what do we need? We need a negative 1, and we need the product to be negative 42. So you got to test and figure out how do you create that negative 1. So if I use positive 7 minus 1, that's positive 1. I need a negative 1. So if you get the number but the wrong sign, what do you think you should do? Just swap the signs. So negative 6 plus a 7. Swap the signs, not the values. Genius. So negative 7 plus 6 equals negative 1, right? So that's why it's good to have a good eraser, because we know we're going to make a mistake. So negative 7 plus 6 gives us negative 1. That's a check. What's the next thing you're supposed to check? Check to see if the product comes out what you needed. So negative 7 times a positive 6 is a negative 42. Check. So you make sure you get the product and you make sure you get the middle term. So when that get double checks, that means I have my number. So what am I putting in? A negative 7 plus a 6. And I'm finished. And I'm finished. And again, if you have a plus 6, a minus 7, it's still the same thing and it's correct. All of your work, a lot of your work, most of your work is scratch work when you're factoring. It's just you figuring out the numbers that's going to make it work. You figuring out the numbers that's going to make it work. Okay? All right, let's look at this problem. $40 minus 13t plus t squared. So after you factor out the GCF, actually before you factor out the GCF or look for GCF, there is like a pre-step. So we'll call it Roman numeral I. You should always make sure your problem is in descending order. You should always make sure your trinomial is in descending order. So when I look at this problem, you should always want the exponent or the term with the largest exponent to be first. So descending order, so I'm going to rewrite this problem. The value should count down. T squared, t to the 1, no t at all, right? So I have it in descending order. There's no greatest common factor. So now I what? Do factors of c. Factors of c that can add or subtract to create a 13. So I'm going to break down 40. 1 times 40, 2 times 20, 8 times 5, 4 times 10. So I'm listing the factors of 40. And when I look at these pairs, what pair do I think can create the 13? 8 and 5. So let's check it. What do I need though? I need a negative 13. So negative 8 plus negative 5 is negative 13. Or you could just have minus, right? And then negative 8 times negative 5 is positive 40. So my 40 is positive, check. My 13 is negative, check. So what are my two numbers? My two numbers are negative 5 and negative 8. And that's factored. And the problem is finished. So you want to always check for descending order. You put it in descending order and then you factor. Put it in descending order and then you factor. Let's look at this. 3x squared plus 30x plus 63. So 3x squared plus 30x plus 63. So we're factoring this. It's in descending order. So when I look at it, 3, 30, 63, there's a greatest common factor present. So I have to factor out that GCF before I do anything. So everybody contains a 3. So I'm going to factor out a 3 from everybody. So that leaves me with x squared plus 10x plus 21. All right. So once you factor out the GCF, then you go through the rest of your problem. You finish factoring a trinomial. So here's where I am. Just like when we did factoring by grouping, you do the GCF, then you continue and factor what's left in the parentheses. So I'm looking at the trinomial x squared plus 10x plus 21. So I'm looking at what? Factors of 21 that can create a 10. Well, the 7 and the 3 can do that, right? 7 and 3. So a positive 7 plus a 3 is a positive 10. And then if I multiplied them together, they would give me the positive 21. So my two sets of parentheses, x plus 3 plus 7, bring down that GCF at the end, and the problem is done. Remember, it's factoring. So everything you do as an answer can be multiplied and checked to see if it gives you back the original problem. I can distribute this, multiply this out, distribute the 3 back, and I'm going to get back 3x squared plus 30x plus 63. All right, that's how we factor trinomials when our a is 1. All right, when our a is 1. All right, and then let's look at this one, x squared. All right, so when you're looking at a problem like this, and the question might be, well, is it in descending order? When you have multiple variables present, it's going to be in the order it's going to be in, okay? So because I have x's and y's, the x squared being first doesn't matter, all right? So I just always leave these in the order they're in when there's usually multiple variables, because x squared or y squared, either one being first is descending order. So see x squared, x, no x at all. All right, so that's how it really is. So you can just leave it in the form it's in. You check for a GCF, which we have none. And then we're going to go ahead and we're going to factor. Factors of the C that can create the middle term. So when we do our 2 sets of parentheses, the first term is going to split as x and x. When you look at the last term, you have a 4y squared. Well, how do we break up a y squared? What created the y squared? A y times a y. So just like you see x squared and we do xx, you see a y squared at the end or a variable squared at the end, you're going to split it just like you would in the first position. So now we're focusing on identifying the numbers that we need. So factors of -4 that can create a 3. So factors of 4 are 1 and 4, 2 and 2. So I'm definitely going to be using the 1 and the 4. That's the only way I can get a 3. So how do I need a -3. So -1 plus 4 is +3. So we're going to switch the sign. So 1 minus 4 is -3. Check. And if you multiply 1 times a -4, you get a -4. So I have double check, which means I'm putting in a +1 and a -4. Okay? And you don't have to have the 1. You could have x plus y times x minus 4y, right? Either one is correct. So that's factoring trinomials when your a is 1. Factoring trinomials when your a is 1. All right, let's see. Let's do r squared minus 3r plus 6. So r squared minus 3r plus 6. So we're doing factors of 6. So we have r and r. And we have factors of 6. That'll give us a 3. So when I look at the factors of 6, I get 1 and 6, 2 and 3. So which pair can somehow add or subtract to create a 3, a -3? 1 and 6 can never give me a 3. I can get a 7, I can get a 5. 2 and 3 can give me a 5, they can give me a 1. These pairs, neither one of these pairs can ever add or subtract to create a -3. So remember from the previous sets of numbers, when we practice with it, what does that mean? It essentially means that there is no factor of 6. There are no factors of 6 that can multiply out to create this -3 here. So if there are no factors that can create the middle term, that means that this is a prime trinomial, or that it cannot be factored. Something that is prime means it only has 2 factors, 1 times itself. So when we say a trinomial is prime, it's saying that there aren't 2 things that can multiply to create this. The only thing you can do to create this is to multiply it by 1. That's what that means when we say prime. There's no way to break this up. There's nothing that distributed, multiplied out, FOILed out to create this trinomial. This trinomial is a prime trinomial because there are no factors of 6 that will ever create a 3. Okay, that's what it means when you see prime or cannot be factored if you have something that's prime or cannot be factored. X squared minus 8x plus 15. So we're doing factors of 15 that can create an 8. So when we do this, what do we have? Well, 3 and 5 can make an 8. So can they make a negative 8 and create the product of a positive 15? Well, negative 3 minus 5 is negative 8. And if you multiply negative times a negative, you would get the positive 15. Once you get a double check, you know it's factorable. You do your 2 sets of parentheses, and then you just put in your values. And we're done. Okay? So factoring trinomials when your A is 1. Factoring trinomials when your A is 1. All right? Hope it helps.